Hey kiddos, we are going to be discussing corresponding parts and a specific type of corresponding triangle called the hypotenuse leg or the HL. Okay, so let's jump right on in. All right, so congruent figures are two figures are congruent if and only if, biconditional by the way, if and only if a transformation or a composition of the transformation maps one of the figures into the other. So, corresponding parts of congruent figures are, in fact, congruent. Go figure. So, in congruent polygons, the corresponding sides and the corresponding angles are supposed to be congruent. So, when triangle DEF is the image of triangle ABC, you can write the congruency statements for the corresponding angles and corresponding sides. Meaning that corresponding angles, let's look at those first. Angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. The dead giveaway here is, notice their markings are identical, okay? So it's kind of what you're looking for here on the markings. Corresponding sides would be AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. All right? So notice again, that's knowing by looking at my markings here. So when you write a congruent statement for two polygons, always list the corresponding vertices in the same order. Okay, congruency statements can be written in more than one way. Two possible congruency statements for these two triangles above are triangle ABC. So notice what we're saying here is that you have to match it. So angle A, since I put the letter A first, has to match with the angle that corresponds to it, which is D. Okay, then I put B second. So B has to correspond with the angle in the second triangle that's the same to it, which is E. Okay, so that's why the order matters. So triangle ABC is congruent to triangle DEF, or we could have named it a different way. We could have gone a different direction, right? I could have named it BCA, which notice changes the order for the second triangle to now EFD. Okay, so you have to make sure that you always match them up. If all the corresponding parts of two triangles are congruent, then the triangles are congruent. If the triangles are congruent, then all the corresponding parts of two triangles are also congruent. Notice throwing some conditional statements, some logic at you guys. All right. So it's just a few properties of triangle congruency are reflexive, symmetric, and transitive. Okay, so reflexive is basically stating that the two triangles are in fact congruent. Or another example would be, let's say I have this triangle with that line in the middle. Notice I really have then, I'm looking at those two triangles, okay? So I'm looking at this triangle here and this triangle here. This line that's in the middle, let's say I label it AB. So I could say line AB is congruent to line AB, and that be the reflexive property because that line corresponds to both triangles. Okay, so that's kind of another way to use the reflexive property. Symmetric property. So notice we're referring to the pictures before, so you guys can look at those. If triangle ABC is congruent to DEF, then we can obviously switch the order and say that triangle DEF is congruent to triangle ABC. Okay, so that's a symmetric. And then transitive property. So let's say we have three triangles, okay, and we have already determined that triangle ABC is congruent to triangle DEF. And we also see that DEF is congruent to triangle JKL. Then we can automatically, right, because of the transitive property, say that the beginning triangle ABC can be congruent to the third triangle JKL because they both are congruent to the middle one. Okay, so that's kind of what transitive means. Then we have the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, so if we have angle A is congruent to angle D and angle B is congruent to angle E, then we hopefully recall that we know the measurements. These three angles added up should equal 180. So therefore, there's only one option that would be left for angle C and for angle F. So therefore, the third angle would have to also be congruent. So for first example, we're going to be identifying corresponding parts. So we're going to write a congruency statement for the triangles, 3 different ways, identifying all pairs of congruent corresponding parts. So congruent angles. Let me pick an angle. So let's go with angle K. And angle K would be considered congruent to angle S. All right, next angle, angle J. Angle J has 2 markings, so the other one that has 2 markings in the second triangle is angle T. And then the other angle, angle L, is congruent to, notice angle L has only 1 marking, and angle R. Okay, so those are my congruent angles. So now let's look at my congruent sides. Let's start off with KJ. KJ is congruent to, now remember, order matters. I did the K first, so that would mean I'd have to go with S first, and then T would match up with it because that matches up with J. So side KJ is congruent to side ST. Then the next one, let's go LK. Side LK, so L I started off with, so I'll have to start off with R, and then R, S are going to be congruent. And then we have JL, and JL would be congruent to, remember, we got to match them up. J matches up with T, and then L matches up with the R, with side TR. Okay? Then for our names of our triangles, so remember, we used not the angle symbol here, we're using the triangle symbol. So triangle, let's say I do triangle JKL, is congruent to triangle. Remember, follow the order. I started off with J, so that means I have to start with T. Then I did K next, so that would be S. And then I did L, which would then be R. Or I could have started off with, let's say, KLJ. So triangle KLJ would be congruent to triangle SRT. And then the last option, or another option, would be triangle LJK would be congruent to triangle, start off with L, so that's R. Then I did J, so that's T, and then S. All right, so that's corresponding parts and how to match them up with angles, sides, and triangles. All right, so example 2, using properties of congruent figures. Notice first thing I did was I actually redrew this polygon here to look similar to the first one, just because it makes it a lot easier for me to see where all my angles are and which ones correspond with each other. Okay, and then I did make particular markings on certain angles, just because it makes my life 10 times easier to visually see what matches up with what. Okay, so my congruent angles are angle D is congruent to angle S. Angle E is congruent to angle P. Angle R is congruent to angle G. And angle Q is congruent to angle F. Now for the congruent sides. DG is going to be congruent to SR. DE is congruent to SP. EF is congruent to PQ. And FG is congruent to QR. Now they want us to solve for x. So to solve for x, I notice that X is located here where QR is. So that is 2X minus 4. And I know that RQ is congruent to GF. So therefore, I can set those 2X minus 4 equal to 12. We're solving for X here, so I'm going to add 4. We get 2X equals 16. Divide both sides by 2, and we get that X is equal to 8. And now for Y, that's a degree, and it's at where Q is. And Q is congruent to F, which is 68. So 6Y plus X, which we already know, equals 68. X is 8. So I'm going to plug that in. Then we're solving for Y. So we're going to subtract 8 to both sides. We get 6Y equals 60. Last step is to divide both sides by 6. And we get Y equals 10. All right, so just like before, I took the time to redraw this second figure so it looks similar to the first. So it matches up my congruent angles and my congruent sides because that's what we need here. So first thing we need to do is solve for X. So I notice DE is congruent to QM. So therefore, X minus 2 equals 8. Solving for X, so I'm going to add 2. This was really simple. 8 plus 2 is 10. So our X value is 10. Now to solve for Y, I notice that angle P is congruent to angle G. So therefore, 3 times X, which we know what X is, plus 2Y equals G is 84. Okay, so 3 times X, which is 10, so that gives me 30 plus 2Y equals 84. We're going to subtract 30 to both sides. 2Y equals 54. Last step is to divide by 2. And we get Y is equal to 27. All right. Using the third angles theorem here, so we're looking for the measurement of BDC, angle BDC, so that's this whole thing, okay, first. Now, they gave us a few other markings here that we need to pay attention to, so I'm going to identify a few things. They've established that that little one there is 30, so therefore that is 30 because they have the exact same markings. Angle A is 45 degrees, so that means angle B, since it has the same marking, is also 45 degrees. Now, to work this out, we need to look at the bigger triangles. Okay, now remember, triangles add up to 180 degrees. Okay, so in this bigger triangle, so let me mark it for you in red so you guys can see it here. This triangle here is the one I'm looking at, okay? CBD, this triangle thing, this whole triangle right there. I know this little piece is 30, this little piece is 45. And I know one section of this whole angle is also 30, so we're missing the other piece. So all we really have to do is add all those together and then subtract it from 180. So 45 plus 30 gives me 105. Subtract that from 180, I'm left with 75. So that would conclude that this angle here has to be 75 degrees. So for the first question, which was angle BDC, which was this whole angle here, those two pieces together, that would be 75 plus 30, which would give me 105 degrees. Now for the next one, CND, angle CND. CND is this angle here. Yep, that angle there. So we already know that two smaller pieces are 30 degrees and 30 degrees, which gives us a total of 60. So 180 minus 60 leaves us with 120 degrees. And then now angle ANC, ANC, ANC. So it's this angle here, and I'll mark it with 3 curves. Okay, so to find this angle here, well, coincidentally, if we know that this is 120, hopefully you see that this is a linear pair. So 180 minus 120 leaves us with that having to be 60 degrees. All right, so suppose you have triangle ABC and it is congruent to triangle MLN. And then you have triangle MLN, which is congruent to triangle UTS. So notice what I went ahead and did is I drew all 3 triangles, and then I made sure that because they're congruent, I made all these markings to show that they are in fact congruent. So what we're given then is that angle B is 62 degrees. So then it would be fair for you to say then, since all 3 triangles are congruent, the angle L is also 62 degrees and angle T is also 62 degrees. And then they also tell us that angle U is 43 degrees, which would mean that M is 43 degrees and A would have to be 43 degrees. And the question is, what is angle N then? Now I notice angle N is here. So if I know 2 sides of a triangle, or sorry, if I know 2 angles of a triangle, then I can easily figure out the third one because all I have to do is add those 2 together and then subtract it from 180. So when we do that, we get a 75 left over, which means angle N has to be 75 degrees. All right, so a particular type of congruency triangle that we're going to talk about here is called the hypotenuse leg. Now, hypotenuse is very specific because you can only have a hypotenuse in a right triangle. So this congruency triangle only applies then to right triangles. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another triangle, then the triangles are congruent. So there's technically 3 things you're looking for. The hypotenuses have to be marked as congruent. One of the legs has to be marked as congruent. And most importantly, you have to have a right degree angle. Okay. If you have those 3 components, then hypotenuse leg exists. All right. So in other words here, I see that I have my right angles. So I can definitely say that angle A is congruent to angle X because they're both 90 degrees, okay? And more importantly, we have a hypotenuse that's marked. Remember, your hypotenuse is across the 90 degrees, which is BC and YZ that are congruent. And I have one leg that's also marked as congruent. AC is congruent to XZ. So because of that, we can establish this as being a hypotenuse leg triangle. All right, so this first example, we're trying to prove hypotenuse leg here. So let's see what we have. GT. So where is GT? GT. Now, first of all, is GT a hypotenuse or a leg? It's across the 90 degrees, so it is a hypotenuse, okay? Because remember, we're looking for 3 things here. The hypotenuse, leg, and a 90 degree, okay? So right now, we do have both hypotenuses marked. GT is congruent to GH, okay? Then I'm looking at angle GKT, angle GKT, angle GKT. Notice that's where the 90 degree is, which is very important. You have to have that. So the one that corresponds to that angle would be angle GKH, which also has the 90 degrees. All right, so far so good. And then you have GK is congruent to, well, what's very unique here is that's the reflexive property being used because both of them have that line. So technically, I can actually prove that GK is congruent in both cases. Or we could have used the other leg because it is also marked. Okay? So notice you had a few options here because technically we could make markings on both of these leg options. So I'm going to use GK as being congruent to GK, just because I wanted to introduce to you guys the concept of reflexive. Okay, so in other words, our congruent statement would be that triangle GHK would be congruent to triangle GTK. All right, so here they give us a few pieces of information. So I'm going to make these markings as I read them. WY is congruent to. Okay, so this whole thing is congruent. That's kind of hard to mark on here right now because I don't want to confuse you. So okay, so just remember that this whole line is congruent to this whole one. Okay, then they say WZ is perpendicular to CY. So WZ perpendicular. So there's a 90 degree. And then XY is perpendicular to CY. So there's another 90 degree. Okay. Are these two triangles then congruent? Well, I'm actually going to separate these two triangles to make my life a little bit easier. So there's that first one. And then here we have the second one, Z, Y, and X. And they did tell me that two of the lines are, in fact, congruent. And that was the WY was congruent to XZ. All right. And then they gave me that. Okay, so yes or no? Well, let's see. Remember, this is a hypotenuse leg situation. We have three things we're looking for. We have to have a hypotenuse that's congruent, a leg that is congruent, and a 90 degree. Right off the bat, hopefully we recognize that we do have both hypotenuses marked as congruent. And hopefully you can see right off the bat that we also have the 90 degrees marked because of this right here, them telling us that there's perpendicular. So the question is, do they have a leg that's also congruent? Now, this is where you have to look at your picture, because hopefully you notice that in both situations, ZY is going to be the same in both of my triangles when I redrew it. So that was supposed to be a Y there, guys. So I can actually mark ZY as congruent in both of those triangles, which means, yes, we have a leg that can be identified as being congruent in these two triangles. So, yes, it is a triangle. And the reason why is because it is a hypotenuse leg.